Hello everyone, this is Mr. B again, and today we're going to be discussing rounding with whole numbers, so I hope you're ready. Now when we talk about rounding, there's typically three methods that we use. It could be place value, number lines, or compatible numbers. And when we talk about place value, which will be the first one we discuss, you may think of something like the underline and circle or rounding with its neighbor. And there's nothing wrong with that, both of those techniques are valid and correct. But this is what really describes rounding with place value. When we look at a number and we decide we want to round to, for example, the thousands place, you'll see that this number is underlined, and that's to help us keep track of what we're rounding to. And the number I have next to it is bolded because that's the really important number in this case, because when we talk about place value, rounding is really more about estimating and making things easier to work with. And what's easier to work with? Most of the time, a 0 is going to be a lot easier than an 8 or a 7. Especially when it comes to adding or multiplying large numbers. So in that case, when we round, we tend to think of it as if it's 5 or higher, we go up. If it's 4 or lower, we stay the same. So in this case, we see that we have a 7 that's bolded, and this 7 tells us that we are in fact going to round up. So our 4 is going to become a 5, and we know that everything to the right of the place value that I'm rounding to becomes a 0. So that's why all of a sudden, instead of a 7 and a 2, I have two zeros followed by the last 0. Now, on our next number we're going to look at, 9,203, I see that my bolded number is a 2, and 2 tells me to stay the same. So that doesn't mean I have 9,200. That would be false. In that case, I would be rounding to the nearest hundreds place. But since I'm rounding to the nearest thousands place, my bolded number still becomes a 0. Everything, including the tens and the ones, becomes a 0. But my underlined digit stays the same. It's still going to be a 9. Now, with a number line, it's actually a little bit easier because I'm given a representation of what I'm rounding. I get to see it on a picture. I get to really just look at it and make a decision. Now that's true in every case except for one, and so I'm going to show that to you one right after this. But first let's start with an easy one. I see that I have the number 1,300 on a number line, and I want to decide if it's closer to 1,000 or 2,000. And so that means, am I going to round it up to 2,000 or let it round down or stay the same and go to 1,000? So I have a 3 as my hundreds place that's guiding it, and it tells me to round down to 1,000. But I can also just look at my number line, and I can, plain as day, see that 1,300 is actually much closer to 1,000. And so, simply put, 1,300 rounds to 1,000. Now, the tricky part. What happens if I have, let's say, 1,500? Well, 1,500, when I look at where it falls on both, it's right in the middle. So I can't really just look at the number line and decide. I have to think back to when I talked about place value. And I said if it's 5 or higher, round up, or 4 or lower, round down or stay the same. And since it's 5 and 1,500 or 1,500, I know that I do in fact round up to 2,000. So keep that in mind. Now, compatible numbers are a bit of a weird or fun topic depending on how creative you can be. Compatible numbers are more about what works for you as the person actually solving a problem rather than following a specific formula like the rest of math. Compatible numbers work differently for different people, and what works for you may not work for me or your neighbor or even your parents, and as long as it's reasonable, there's nothing wrong with that. Now, compatible numbers have a key word, and I just used it, and it's reasonable. Let's look at these two sets of numbers here. I have 2,859 plus 4,905. Now, you could add this as it is, and it would be kind of complicated between carrying, regrouping, and finding a sum, or I can use compatible numbers and change it to 3,000 plus 5,000, and I'll get 8,000. Because remember, I'm estimating or rounding, so I'm still doing what I'm supposed to do. But you may look at this and not want to use 3,000 and 5,000. You may want to use 2,900 and 4,900 because that just may work better for you. Or you may prefer 2,850 plus 4,900. Doesn't matter what you choose as long as it's reasonable. So what I mean by that is don't look at this problem and decide to give me 10,000 plus 40,000 because unfortunately that's just not reasonable. Okay? So keep that in mind. Now, I want you to round with place value and try to solve these 6 problems. Remember, the bolded number is your guide and the underlined number is the number you're rounding to. So take a minute and pause it if you need to, or work through it. Here you go. There you go. I hope you also enjoyed that drive-by by my wonderful partner, Miss Maggie Mays. Now, I want you to also solve these 3 problems using a number line. Take your time if you need to, and remember to look at the number line and do your best. And finally, estimate using compatible numbers. Remember, as long as it's reasonable, it's a-okay. If you would prefer, you can always just round them, and that'll give you a reasonable answer. There's nothing wrong with that, because most of the time, the higher you round to, so for example, if you round these to the nearest 1,000, and you round these to the nearest 1,000, and these to the nearest 1,000, and they're the same numbers, you'll get a compatible number. You may choose to round these to the thousands, these to the hundreds, and these to the tens, and you'll be just fine. It's your choice. Good luck.